Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have discussed three terms related to propagation of sound, or you can also say related to propagation of wave. And those three terms were amplitude, time period, and frequency. There are two other important terms which we must know regarding the propagation of sound, or you can also say propagation of any wave. What are those two terms? Let us discuss. Okay, so I hope you have watched the previous video. If you have not watched the previous videos related to sound, you will not be able to understand the concepts properly. So please, if you have not watched the previous video, please do watch the previous videos to have a good sound knowledge about the terms we are talking about. Okay, so the fourth term that we are going to discuss today is what is the term? It is wavelength. Okay, so it is wavelength. So what is wavelength? Okay, what is wavelength? Now see, when a body is vibrating, when the body is set to complete one vibration, when it starts from its mean position and again comes back to its mean position. So if I consider this pen vibrating like this to and fro, and if this is the mean position of the pen starts from this position, if we just start the stopwatch, 0 second is the mean position, then it slowly with progress of time moves to the left, then to the mean position again, then to the right, extreme right, then again to the mean position, back to its mean position. Now this is one complete vibration or one complete oscillation. Now try to understand this, that time taken to complete this one vibration or one oscillation is the time period. So during this time, the propagation, the wave, the disturbance that has been created by the movement of this pen has traveled a certain distance through the medium, isn't it? Has traveled a certain distance through the medium. So the distance that the wave has traveled, okay, the wave has traveled during its completion of the one wave, one vibration can be regarded as the time period, wavelength. So wavelength can be defined in two ways. One is that it can be regarded as distance moved by the wave when the particle completes one vibration. Okay, rather it can be also said that it is when the particle completes one vibration. Okay, or instead of this writing this line, you can also say that distance moved by the wave, or you can also write, or distance moved by the wave, from here we are just adding on, okay, distance moved by the wave during one time period, so this can also be the wavelength. Okay, so do you understand? So wavelength is the distance moved by the wave when the particle completes one vibration. This is also true, and in other words you can also say that it is the distance moved by the wave during one time period. So this is the wavelength. Okay, if you consider a longitudinal wave, we have discussed about longitudinal wave. Now with longitudinal wave, two terms are associated. One is compression and one is rarefaction. I think you remember it. Now we can also consider that the wavelength is a distance between two successive such compressions or two successive such rarefactions. That can be also regarded as the wavelength, that distance. Or in case of, you consider a transverse wave. For the transverse wave, the wavelength can also be regarded as the distance between two successive crest or two successive trough. That can be also be the wavelength. Why? Because see, when we are saying for longitudinal wave two successive compressions, when two successive compressions are created, think of the fact that the pen moves to the extreme left, creates one compression, okay, then comes to the extreme right, and then again when moves to the extreme left, creates another compression. So if we start from this extreme left position, the pen goes to extreme right and then comes back to the extreme left. This is one complete vibration. So in between two compressions, when two compressions are actually created, in between those two compressions, one vibration is completed. Okay, likewise in similar manner, you can also say that the between two successive rarefactions, that distance can also be regarded as wavelength, because between two successive rarefactions, one vibration is completed. And in a similar manner, for transverse wave, crest, what are the two crests? When you are saying that two crests have been completed, we can regard that the vibration of that particle has been, one vibration of the particle has been completed. Or rather in troughs, two successive troughs. When two successive troughs are seen to be repeated, then it can be imagined that yes, one vibration has been completed. So wavelength can also be stated in terms of those compression or rarefactions, that it is the distance between the two successive compressions or two successive rarefactions for longitudinal wave and two successive crest or two successive trough for a transverse wave. So I think the concept is clear. Now as wavelength is some kind of length. So definitely wavelength, this wavelength should have a SI unit of what? SI unit of meter? Yes, definitely meter, because it is one kind of distance, one kind of length. So length has a SI unit of meter. So definitely wavelength will also have a unit of meter. Okay. Now the next thing that comes is the wave velocity. So what is wave velocity? Okay. So the fifth term that comes is the wave velocity. Now what is wave velocity? Now the wave is propagating, isn't it? The wave is propagating with respect to time. So anything that propagates with respect to time, it covers a certain distance in a certain time. It is a certain displacement in a certain time. Then what you say? That body has a certain velocity, isn't it? When a car has a certain displacement within a certain interval of time, we say that the car has a certain velocity, isn't it? So likewise for the propagation of wave also, the wave is propagating within a fixed interval of time, isn't it? It is moving from one place to another place. It is having a particular displacement within a period of time, isn't it? So it's very easy. So wave velocity can be defined as the distance traveled by the wave in unit time. Now that unit time can be 1 second, can be 1 minute, can be 1 hour, anything, but generally we take it as to be 1 second. So wave velocity can be regarded as distance traveled by wave in unit time. Okay, in unit time. This unit time can be 1 second, can be 1 minute, can be 1 hour. Generally it is taken to be 1 second. Okay, so that is what we call as wave velocity, distance traveled by the wave in unit time. So what can be the SI unit? Yes, definitely velocity. You know the velocity have a SI unit of meter per second. So definitely the SI unit of wave velocity will also be meter per second, m s to the power minus 1, meter second inverse. Okay, so I think wave velocity is clear. Now it must be noted that wave velocity mainly depends on two factors of the medium. Okay, this wave velocity depends on two factors of the medium. What are those two factors? Okay, so it depends on two factors. Okay, is it visible? Yeah, is it visible? So it depends on two factors. Depends on two factors. What are the two factors? One is the elasticity of the medium. Okay, elasticity. Okay, and the second is the density of the medium. These are the two factors that actually affects the wave velocity. That these two factors affect how much distance the wave travels within a certain unit time, within 1 second, within 1 minute or 1 hour. So these are the two factors that affects the wave velocity. Okay, so today we have completed the topics related or terms related to propagation of wave, propagation of sound wave. Okay. Today we will end our class here. In the next class, we will be discussing two very important topic: displacement time graph for a wave and distance displacement graph for a wave. Okay, displacement distance graph for a wave. So two things that we are going to discuss on the next class is displacement time graph and displacement distance graph. Okay, so we will not be studying those two topics in today's class. Okay, time is not permitting us. Okay, so we have made a short video and completed the terms related to wave propagation. Okay, so if you have any query, do mention it in the comment box. We will be happy to solve the problem. And with that, we are coming to the end of the class. Please do study well. Till the next video. Goodbye. Thank you.